Hello to everybody. Enrico Quagliarini is now speaking. First of all, I hope you and your family are okay despite the health emergency underway due to coronavirus. Well, this is the first time I do my presentation in a remote way, but times change and we have to adapt considerably. This presentation provides a first overview of the BE S2ECURe project, which acronym means Make Built Environment Safer in Slow and Emergency Conditions through Behavioral Assisted Design Resilient Solution. This project is funded under the Project of Relevant National Interest by the Italian Ministry of Education, University and Research on the basis of a competitive grant program at the Italian level. 5 research groups from 5 Italian universities work at the project under the coordination of the Università, Politecnica delle Marche. And you can see on this slide the Italian university involved in such a project. The total budget is about 1 million euros and will involve activities from 2019 to 2022. The project proposes this holistic cross-hazards and user behavior-centered approach to define multi-disasters resilience metric for emergency conditions in the built environment. The project is aware that the built environment in our cities is a complex network of buildings, open spaces, and infrastructures prone to disasters. The risk in this built environment is due mainly to the site characteristics, including, for example, location in risk-prone areas, and the relation between the elements in the urban layout, then the physical layout of open spaces and facing buildings characteristics, besides the intangible cultural and social values of the built environment, then the human presences in terms of number but also of users' typologies, for example, age, gender, mission abilities, and so on, as well as of human behaviors depending on the disaster condition. Also organizational issues in spaces, planning and management, even in ordinary conditions, can play a role. Moreover, according to these previous issues, time-dependent variables such as different occupancy types and uses over time and space can increase the complexity and the risks. Finally, risk management and response actions represent a higher level of interaction elements in the built environment. Two types of disaster can be pointed out. Sudden onset disasters, that is triggered by a hazardous event that emerges quickly or unexpectedly, like earthquakes, terroristic acts, fire. They are catastrophic because of their immediate consequences on built environment, with human, social, economic, cultural losses for the community. Secondly, we have the so-called slow onset disasters. They emerge gradually over time, like pollution, heat waves, mainly induced by anthropic factors. For instance, the combination of strong and prolonged summer heat waves with poor air quality greatly compounds negative effects and can pose major and invisible risks to human health, with poor life quality and high social costs. Effects of such disasters on the built environment and its users are mainly based on its poor design in respect to effective user behaviors, thus promoting deterministic and simplified rules. For example, if we consider floods, motion tasks are generally related only to water flows and do not consider microscopic interaction between, for example, pedestrians. Then, regulations and guidelines for design practices limitedly consider these aspects, especially for outdoor built environments. These factors are usually combined with inappropriate users' behavior, also due to poor risk awareness. For instance, the avoidance of safety procedures activation, as you can see in the videos on this slide. Inappropriate infrastructures in respect to current lifestyle by, for example, considering population growth or particular climate conditions, such as particular mass events or tourist hubs. In this general view, the following main limits can be underlined. Current risk reduction strategies are usually centered on the building, especially for sudden onset disaster. Open spaces near and between buildings are normally excluded in such strategies. Interaction between buildings and surrounding areas for risk reduction seem to be generally ignored, although they could lead to unpredictable critical safety conditions for urban areas. Our risk assessment approaches and related regulations normally consider the separation by risk affecting factors, as well as by causes and effects of the sudden onset disaster and slow onset disaster combination. They should be merged by also considering the potential of built environment as a resilience increasing element. Then combined risk metrics should be also defined too, especially in view of a common evidence on how risk conditions could affect the overall safety of the built environment and its users. Finally, strategies do not generally consider impacts on human response and behaviors. Their impact in the transition from closed to open spaces in the built environment in the outdoor is generally overlooked by simulation and design tools and emergency support systems. In view of the above, this research wants to develop methods and tools for the representation of real user behaviors, then link mitigation, prevention, and risk control strategies between sudden onset disasters and slow onset disasters by using multi-scale and multi-hazard approaches. Then overcoming the lack of regulations and guidelines for outdoor built environments, starting from behavior-based analysis and simulation design tools, as well as resilience metrics. Finally, improve the attention to training, information, and risk education of users in built environment. Due to recent national and international natural and anthropic disasters and following European research trends in safe, secure, and clean society, BE S2ECURe will be focused on earthquake and terroristic acts, as sudden onset disasters. They also imply the necessity of evacuating the built environment by its occupants. Air pollution and heat wave as slow onset disasters are then selected. They imply daily use related issues by the citizens and are strongly related to the climate change. The application to the Italian context by focusing on a historical built environment at risk is provided because of their relevant impact in terms of critical characteristics. On these two bases, the characteristics affecting the built environment are then correlated to the sudden onset disaster and the slow onset disaster issues by providing a list of characterizing elements for the built environment itself. Sub-factors for the typological classification are proposed. For example, in this slide, the morphological characteristics of open spaces in the built environment are summarized. Then the characteristics are combined so as to outline risk metrics related to specific disaster analyzed in the project, so as to consider the possible risk level of the built environment in relation to hazard and capability, vulnerability and damage scenarios, as well as exposure variables according to existing literatures. BE S2ECURe will innovatively combine the study of crowding conditions with analysis of disaster conditions and behavioral drivers, which regard the individual characteristics in terms of, for example, gender, age, previous tasks, the activation of recommended behaviors, also in relation to emergency management tasks, and the interaction with the built environment elements and its disaster-induced conditions. In this sense, behaviors from sudden onset disaster will be mainly considered in relation to damages, while for slow onset disasters, perception issues in respect to environmental conditions. On the review of factors influencing the built environment and the users at risk, typology classification of the built environment will be proposed by merging sudden onset disaster and slow onset disaster aspects by firstly focusing on the morphology and construction technology of the built environment itself. So, built environment typologies will be created. Interfaces between buildings, open spaces, infrastructures, for example, facades, one square, street, pedestrian route, and so on, will be characterized. Besides, typical exposure of users will be characterized, also including the number of exposed people and exceptional conditions, due, for instance, to crowding. BEAM and VR and AR techniques will be used to provide representation of built environment typologies, moving towards simulation and training tools. Then, basic and typical combination between built environment typologies, human factor, disaster-affected modification will be combined into simulation models. They will consider short time of simulation for sudden onset disasters, mainly focusing on critical evacuation conditions, which can last from many minutes to some hours. For slow onset disasters, simulation's timing will involve long periods, up to seasonal evaluation, due to the fruition model of the built environment, and with the possibility to combine the occurrence of sudden onset disasters during the time. Modeling and simulating such interaction in disaster conditions will allow to define built environment design and management strategies based on the pursued holistic and behavior-based approach of BE S2ECURe. In fact, multi-risk and multi-scale metrics will be defined to rank the built environment typologies in terms of resilience, through also moving towards a resilience-based inventory of built environment typologies and of implementable solutions involving the architectural space, such as by layout modifications, the emergency supporting facilities, such as by building components and devices to support and guide people, and the emergency management of planning. These solutions will be centered on a proactive adaptation of the built environment, depending on human needs and behaviors, thus making the host community aware of correct emergency choices. In this sense, redundancy criteria for solutions will be pursued, since safety increasing strategies will be allocated to different elements regarding the built environment, the users, biopreparedness, and the practitioner management. Simulation tools will determine their preliminary effectiveness in slow onset disaster and sudden onset disaster, and in disaster combination, by taking into account the proposed resilience metrics. Tools and guidelines for improving the built environment resilience will be obtained by demonstrating the method capabilities through significant case studies representing the built environment typologies. Meanwhile, virtual training to understand how training preparedness solutions can increase the human factors related resilience will be carried out. These activities will be focused on the direct user's engagement and perception at different levels. Designers and SEB-20 could better understand the impact of behavioral-based strategies and solutions inventory while having data on the capabilities of simulation tools. Local authorities will raise their awareness towards such strategies. Finally, training actions on citizens will test the effectiveness of the solutions in an immersive environment, giving feedback to the previous evaluation process, while increasing end users' awareness to boost the community safety. In this slide, you can see the VR test carried out by the project actions. The individual moved in a building during a terroristic act evacuation by using an innovative equation wayfinding system, thus improving the individual's response to the event in respect to the use of traditional solutions. In relation to the main elements characterizing the built environment risk, as described in the first slide of this presentation, we can mainly point out the following impacts of the project and its framework. First of all, regarding the built environment and its risks, hotspots for man-environment interaction in emergency will be provided, also according to typological categories. Hence, the microscale based planning of safety will move from its layout up to its composing elements, thanks to the definition of priority intervention maps in the whole urban scale. Secondly, regarding human-built environment interactions, the basis of the design on users' behaviors will move towards the basis for developing interaction solutions to avoid wrong emergency choices and promoting practices for participatory training and communication. This will provide social impacts on communities at risk. Scientific and technical advances will also regard the criteria for implementing smart interactive components. Finally, regarding operational issues, proposed guidelines will firstly improve safety and well-being standards, also in the view of rating system to assess the built environment resilience. Stakeholders will be supported by simulation toolkits during the design and management process to evaluate new user fruition model. Also, for example, in view of other risks such as the pandemics. These will boost action to anticipate the possible disaster to move towards sustainable cost strategies. In conclusion, this work shows the BE S2ECURE framework to analyze the built environment and its risks, define and test risk mitigation solutions, and improve risk awareness against sudden onset disaster and slow onset disasters by promoting a holistic user-centered approach. Activities have achieved the definition and characterization of the built environment as a network of buildings, infrastructures, and connecting spaces in reference to the considered disasters and user typologies. Preliminary results are also shown in this conference section. They concern the morphological system of open spaces in built environment prone to sudden onset disaster and slow onset disaster events factors in Italian built environment archetypes. for slow onset disasters. A preliminary assessment of techniques for behavioral analysis to model the human factor and the response in emergency conditions will be proposed by the work titled Understanding Human Behaviors in Earthquakes to Improve Safety in Built Environments, a state of the art on sustainable and validated investigation tools. Thank you for your kind attention.